Okay, so today we are changing our numbers, or our complex numbers, in polar form into rectangular form. So if we have these guys, this is our real part and our imaginary part of our complex numbers, because remember it's a plus bi. If I wanted to find the moduli is this cute little line right here, and until now we've been calling it the moduli. But we are going to now call it r, so that means the same thing. So remember, to do that, we have Pythagorean theorem, and we do a squared and b squared, and then we take the square root to figure out what c was. So that's what we're going to do here. So we have the square root of -7 squared and 11 squared. And if we take the square root of that guy, we get about 13.0. And the same thing with these other pieces. Here's your a and your b, and your a and your b, and your a and your b. It doesn't matter if it's an ordered pair or if it's actually written as a complex number. In order to figure out the r, or the moduli, you do the square root of both of them squared and added together. Okay, so now let's talk about the next formula. Using this information that we have here, we can gather from this that a plus bi is the same thing as r times cosine of theta and I times sine of theta. So this is your real and this is your imaginary, and again, we set up a trig ratio, which I'm not going to do right now because it takes too much time. Then, if I were to factor these guys, oh no, I forgot my I times r times sine of theta. Okay, so between the two of these, the greatest common factor is r, so we take the r out, and we're left with cosine of theta and I sine of theta. And we're going to use that to change our numbers from complex into polar form. Okay, so when we are doing this, we have 3 steps. We've got to find the modulus, which is our r. Then we're going to find theta. Now, theta, using this piece of information, theta is going to equal the inverse of tan, and tan will be b over a. And this is because if I'm standing here at this cute little theta, and I'm given these two sides, but I need to figure out what my theta is, then that is an opposite side, an adjacent side, and opposite and adjacent is TOA. And the ratio for TOA is opposite over adjacent, and our opposite is our B, and our adjacent is A. So again, we get this information from our cute little picture. And then our last step is to write in polar form, so I'll show you what to do. Okay, example 1. So the first thing we're going to do is we're going to figure out our r. So our r is the square root of 3 squared and 3 squared. So 3 squared is 9, and 3 squared is 9, and that makes 18. And if we reduce this radical, we get 3 root 2. Okay, so then what we're going to do is we're going to find theta. This part can get a little tricky. So theta is equal to the inverse of tan, and that is our b. So remember, this is a and b. So b over, oops, I almost wrote a. I wanted to write 3, silly. A. Okay, now we're going to do that in our calculator. The inverse of tan, 3 over 3, and that gives us 45. Okay, so that is a 45 degrees. Okay, all right, so now this is where you have to use some critical thinking. If I were to graph this one, I have my my coordinate plane, which we're going to think about as a unit circle. So if I start on this axis and then I spin around and I get back here, then that's 360 degrees, right? So each of these little quadrants, so remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So each one of these quadrants is worth 90 degrees. Okay, so we want our theta to match where we originally graphed this guy. So we're going to graph this guy. So this guy is to the right 3 and then up 3. So he would be like here. And if I were to draw 45 degrees, moving this axis first, up here, 45 degrees would be about that. So we're good to go. I don't have to change my theta. Sometimes you have to change your theta to match, and I'll show you what that looks like in a minute. Okay, so now we just plug into our cute little new equation that we wrote up here. So we take our r, which is 3 root 2, and we multiply that by cosine of 45 degrees and I sine of 45 degrees. Okay, and that is it. That is written in polar form. We don't have to reduce anything. We're all done. Okay, so B. This one, let's slide the paper. Okay, so for this guy, again, you start off figuring out our r. So our r is the square root of negative root 3 squared and 1 squared. So negative root 3 squared and 1 squared, so this will end up giving us 2 for our r. Okay, so now let's do theta. So theta is the inverse of tangent, and then it's b over a. So 1 over, negative root 3, like that. When you plug that, oh no, sorry. There we go. Okay, sorry about that. When you plug this into the calculator, then you end up with negative 30. Okay, so now let's think about this for a second. Again, on my graph, if I graph this guy right here, I'm going to go to the left and then up, so here. Now if I graph negative 30 starting here would be down this way. So what I need to do is I need to get this new line to go all the way over here and swing around to this spot. So if I wanted to move this line all the way up here, then what I would need to do is I would need to add to it 180 degrees. And that will put this new line where it's supposed to be. So negative 30 and 180 make 150, and now we can write our polar form. So we have 2, our r, times our cosine of theta, plus I sine of theta. Like that. So you just have to think about where your line is after you get your tangent and where it needs to be. Okay, so I'm going to do, I guess I'm going to do both of them really fast. Okay, so on this one, okay, we're struggling. There we are. Sorry. So on C, we're going to do the same thing. So r equals, so the square root of 0 squared and 2 squared, which will give us 2. And then we do our theta, the inverse of tangent, b over a. Now, when we do this in the calculator, we can't put a 0 underneath. It's not going to work. So let's just look at the picture. If I were to graph this guy, 0, 2 is here, right? So to go from here all the way up there is how many degrees? Oh, well, that's 90 degrees. So that's what we're going to pick. So now we're going to write, we have 2 times cosine of 90 and I sine of 90. And there's our answer. Okay, on D, this one, so we start with our r, so we're going to take the square root of negative 2 squared and negative 4 squared. And when we do that, we get 20. And if we reduce this, we get 2 root 5. Oops, over there. Okay, now we need to figure out our inverse, or our theta. So we have negative 4 over negative 2. And when we plug that in the calculator, we get 63 degrees. So think about the picture. If I graph this guy, negative 2, negative 4 will be down here. If I graph 63 degrees, oh, you cannot see that. If I graph 63 degrees, then that will be moving this piece up here is 63 degrees. So to get our new line where our original was, I'm going to have to add 180 degrees to it. So that gives us 243 degrees. So then we write, we take our r, 2 root 5, times cosine of 243, and I sine of 243, and there we are. Okay, last but not least, on the bottom, we have to write our answers into rectangular form. So basically what's going to happen is we're going to distribute this cute little guy, and we're going to distribute this cute little guy. So on here, we have the root 2 times cosine of 135 and root 2 times sine of 135. I don't know why I wrote so many parentheses, but look at all of them. Okay, so if we plug these guys into our calculator, we get for this one, we end up with -1, and for this one, we end up with a +1. But this looks really weird, so we're just going to write it correctly, 1 plus I, or -1 plus just I like this. So this is rectangular form. Oh, actually, this guy right here is our complex. And if I wanted to write it in rectangular form, that's like the ordered pair after you graph it. So if I went -1, +1, that would be -1, +1 to graph this guy on our coordinate plane. So this is it written in rectangular form. So many forms. So ordered pairs is rectangular, no ordered pairs is complex, with our sines and cosine is polar. So one more over here, so we take our cute little root 3 and we distribute it or multiply it to cosine of 210, not 120. 210, and I root 3 times sine of 210. Oops. So if I do that, for this guy, I get -3/2. And then for this guy, I end up with -√3/2, but it has an I. Let's write it better. -3, 2 minus √3, 2I. Looks better. Okay, and then this is my complex. If I were to graph this guy, I would go to the left, -3/2, and then I would go down, -√3/2, and this is my rectangular form. Okay, if you have any questions, you get stuck, let me know. Have a great day, guys. Bye.